Hello, and welcome to this Price of Job tutorial. In this video, we will explain how to use the timber Flitch beam calculator to BS5268 through an example. To get started, we'll go to the top navigation blue toolbar and select Engineering, and then browse through the module toolbar where we can select from a variety of different engineering modules. And here we can open the Flitch beams category and then select Flitch beam to BS5268 and BS449. The module appears in the left sidebar within this folder, titled Structure by default. We can click on the pencil icon to rename the module folder to something more project relevant, such as Extension. Next to the module itself, there are three dots to open the module options menu. Here we can rename, duplicate the module, move the module, or delete the module. Let's rename this module to something more specific to the calculation we're about to perform. Say, for example, ground floor Flitch beam number 1, and save. And now we can start the timber Flitch beam design. Initially, we enter the effective length, or effective span as we call it. This should be in millimeters. The effective span is the clear span of the opening plus the bearing on one side plus the bearing on the other side. In our example, the clear span is 1,800 millimeters, and the bearing on one side is 100 millimeters, and the bearing on the other side is 100 millimeters. So for this example, we'll use an effective span of 2,000 millimeters. We can input that by using the slider to select the number we wish, or we can just input it manually. If we click the selection on the left-hand side, we can add a cantilever to this side. If we click this checkbox on the right-hand side, we can add a cantilever to the right-hand side. For this example, we don't have any cantilevers, so we'll leave these boxes unchecked. We recommend using a bearing length of at least 100 millimeters. Sometimes longer bearing is required to satisfy the bearing stress check. Utilization limit is recommended to be set at 99%. You can learn more about utilization limits in the explanations video we have among our other tutorials. Next, we'll click the Options button to open our safety factors and deflection limit. For the safety factors, it is recommended to set these to unity for both permanent dead load and for variable imposed live loads. So these should be a factor of 1. Under the options, we can see there are three different service classes. Service class 1 is when we have a heated and dry environment. Service class 2 is when we have a cold and dry environment. And service class 3 is when the timber is exposed to weather. For example, a timber Flitch beam that is covered half by a roof and half uncovered and exposed to the weather conditions, such as rain. For this example, we'll use Service Class 2 for a cold and dry environment. Next, we'll look at the load duration, and we see there are 4 different options here. For long term, this is usually dead loading, such as self-weight or storage combined with permanent loading. In this case, we would use a factor of 1.0. For medium term, this is usually snow or temporary imposed loading combined with dead loading. In this case, we'd use a factor of 1.25. For short term, this is usually wind or snow with wind combined with dead and imposed loading. In this case, we would use 1.5. And for very short term, this is usually wind combined with dead and imposed loading. In this case, we would use a factor of 1.75. For this example, we will use medium term with a factor of 1.25. Next is the depth to breadth ratio. Here you will need to identify the restraint conditions of the end supports and the compressive edge of the timber Flitch beam. This is usually a difficult thing to do. Thus, conservatively, you can choose either no lateral support or ends held in position. You also have options for ends held in position and member held in line by purlins or tie rod, ends held in position and compression edge held in line as by connection of sheathing, deck, or joists, ends held in position and compression edge held in line as by connection of sheathing, deck, or joists together with bridging or blocking, or ends held in position and both ends held in line. For this example, we'll use number 7, ends of the beam held in position with both edges held in line. After that, we have 3 boxes. If the timber Flitch beam is acting as a trimmer joist or lintel, then you can check this box. If we refer to the results description under the modification factors, we see that this will change the load sharing factor from 1 to 1.1. This will increase the strength or load bearing capacity of the timber Flitch beam. If the timber Flitch is part of a load sharing system, such as roof joists or floor joists, then you can click this box. and this will change the load sharing factor from 1 to 1.1. This will increase the strength or load-bearing capacity of the timber flitch beam. If the timber flitch beam has a wane at the bearing, then you should click the third box. This will reduce the strength of the timber beam. And the final section of this window is for deflection limit. Here you can choose whether to consider for dead loading only, live loading only, or both dead and live loadings combined. Maximum deflection limit is recommended to be set at span multiplied by 0.003, or a preset value of 14 mm for dead and live loadings combined. The calculator uses the minimum of these two values. Span multiplied by 0.002 is used when the timber flitch beam is above a brittle element, such as a bifolding door. Such a deflection limit will usually demand a deeper flitch timber beam section than the 0.003 multiplied by effective span deflection limit. For this example, we will choose span multiplied by 0.003, or 14 mm for dead and live loadings combined. And then we can close this options window. The next design stage is for loading input. This is where we answer the question, what is the timber flitch beam going to support? If we want the self-weight of the timber flitch beam to be included in the calculations, then we would select this box. In this example, we have a timber trimmer beam with a dead loading of 1 kN and a live loading of 1.2 kN. This trimmer joist is applied in the middle of the timber flitch beam. We also have timber floor joists from both sides supported off the timber flitch beam. On one side, the timber floor joists span 2,000 mm, and on the other side, the timber floor joists span 2,000 mm. Hence, half of the loading on one side and half of the loading on the other side is supported off of the timber flitch beam. This is 2,000 mm divided by 2 on one side, and 2,000 mm divided by 2 on the other side, which gives us a width of loading perpendicular to the flitch beam of 2,000 mm. Let's see how to enter this into the price of job calculator. Under the loading stage, we'll click the plus add new load button, and input a title for our first load. In this case, we'll start with the timber trimmer joist. And for load type, this is set to uniformly distributed load by default, so we'll change this to a point load, as our timber trimmer joist is mounted upon the center of our timber flitch beam. Then we can input our dead and live loadings. If we refer to our example, we'll see these values are 1.0 kilonewtons and 1.2 kilonewtons respectively. So we can input those here, 1 kilonewton for dead load and 1.2 kilonewtons for live load. And our point load will be applied in the middle of our timber flitch beam. So since the total effective span is 2,000 millimeters, half of that would be 1,000 millimeters. So we can input that value here, 1,000 millimeters. And that takes care of our timber trimmer joist. Next, we'll click the plus add new load button again, and this time we'll input the timber floor joists. And because this is a more standard calculation, we can simply click the pencil icon here to open the load editor, and then click the drop-down menu arrow here to open the price of job template library. And from there we can select timber floors. And this automatically populates our calculator with all the standard measurements for timber floor, including the boarding, insulation, joists, plasterboard and skim, and imposed floor loads for residential use. If we need to add any extra rows here, we can do so by clicking the plus add row button. For example, we might add some plywood with a dead load of 1.2 kilonewtons. And then we can use these grab handles here to reorder our rows however we wish. Also, Price of Job makes it even easier by allowing you to access a library of templates by clicking this template button. Then you can browse through the categories, including roof coverings, imposed loads, boarding, insulation, timber, finishes, masonry, and concrete. So let's take a look at the boarding category and select some 18mm plywood. By selecting on this material, it is automatically added to our calculator here, and we can close this window, and then reorder our rows however we wish. Now, if we have any duplicate items here that we would like to delete, we can remove that by simply clicking the bin icon here on the right. You can change any of these values manually by simply clicking in the box and making the edits required. So let's change our plasterboard and skim to 0.18 kilonewtons per square meter, and our imposed floor load for residential use also to 1.8 kilonewtons per square meter. If you expect to use these same inputs again in the future, you may wish to save this as a new template. And we can do that by clicking on the drop-down arrow here, and then scrolling to the bottom to your custom list, where we can save this as a new template. We'll give our custom template a custom name. We'll just say timber floor for residential use. It will simply be saved to our custom list. And now when we check the templates drop-down arrow, we can scroll down to our custom list and see this new template has been saved for future use. If we no longer need any of these templates, we can simply delete them by clicking the bin icon on the right. Confirm the deletion, and then we can go back to our drop-down menu, scroll down to our custom list, and see that our deletion was successful. After that, we'll input the width of load perpendicular to the beam, which we recall from our example is 2000 millimeters. So we can input that value here, 2000. And then we can close the load editor window. And we can see that the calculator has automatically supplied both our dead and live loadings. For the load type, the timber floor joists are a uniformly distributed load, which is already selected by default, so we don't need to change this. If we click this checkbox for Show Load Details, then a table with all the load details will be included in the Structural Calculations report. If we uncheck this box, then the table of load details will not be included in the report. We'll leave this checked. Next, we can take a look at the last section on the right for the section. AutoSearch will automatically calculate the optimal section for us, but if we unselect this, then we can input the values manually. First, we would select the quantity of timber beams that we have. We can choose from 1 to 5 timber beam elements. So for this example, we will choose 3 timber beam elements. Then we would select the width and depth. For this example, we'll select 50 millimeters for the width and 225 millimeters for the depth. Next is the timber strength class, or timber grade as we call it. Usually we choose between C16 to C24 for softwood. For this example, we'll use C24. For the steel grade, this is where you would enter the steel strength. Usually we choose S275 or S355 for steel. For this example, we'll use S355 grade 50. For the steel quantity, here we define whether the steel plates are between the beams only, like the example diagram shows here at the top of the description, or whether the steel plates are between the beams and on the sides as well, as we can see here in this description diagram. For this example, we'll use between beams only. For the steel thickness, here we would enter the thickness of the steel plates. Usually we don't want the steel plates to be very thick, so the overall self-weight of the flitch beam is reduced. So usually we choose between 6 millimeters to 12 millimeters. For this example, we'll choose 10 millimeters. For the depth of the steel plate, here we enter the depth of the steel plate. It is recommended to use a depth of steel plate equal to or almost equal to the depth of the timber beam. So in this case, we would use 220 millimeters. For the bolt diameter, here we enter the diameter of bolts that connect the timber members and the steel members. Usually this is 12 millimeters. And then we have bolt spacing, and in this selection we choose the spacing of the bolts. The calculator may not allow you to enter a value that is not acceptable. For example, if we try to input a value of 1 millimeter, then the calculator interprets this as a minimum of 48 millimeters. On the other hand, if we were to input a value of 1000 millimeters, then the calculator would interpret this as the maximum value of 563 millimeters. The modulus of elasticity affects the structural calculations. It mainly affects the deflection calculations, but changing the modulus of elasticity from the mean value to the minimum value can have a drastic effect to the design. The mean modulus of elasticity should be used to calculate deflections and displacements under both dead and imposed loads, unless the imposed load is for an area intended for mechanical plant and equipment, or for storage, or for floors subject to vibrations, for example a gymnasium or ballroom, in which case the minimum modulus of elasticity should be used. In this example, we will use the mean value. The Auto Search feature will help us to optimize the timber flitch beam width and depth. By leaving the Auto Search feature unchecked, we can choose the width and depth that we want. Or if we click the auto search feature only for the width, then the calculator will optimize the width for a given depth based on the rest of the input of the previous sections. Alternately, if we check the auto search feature only for the depth, then the calculator will optimize the depth for a given width based on the input of the previous sections. And we can see that the calculator also automatically changed the depth of the steel plate. Next, we'll take a look at the results. In this section, we can see a summary of the results. You can see that all checks have a status of pass. And also, we can see the utilization factors. In the following sections, we can see the design diagrams, the loading details, including the optional load details table, which we chose to display by checking the show load details box here on the right, as well as the supports, beam details, load proportion, modification factors, and the structural checks in detail. Now that this timber flitch beam is done, if you have to do the same calculations for another timber flitch beam, instead of starting all over again from scratch, you can save a lot of time by simply clicking the three dots here next to the module here to open the options menu, and then select Duplicate Module. Now we can use the three dots again to rename this new module. We'll call this one Ground Floor Flitch Beam number 2, and save. And now all we have to do is modify the values for the new timber flitch beam. When you are ready, you can click on the Reports tab here in the left-hand sidebar. And here you'll see the structural calculations page. If we click Export as PDF, you'll see that your logo will appear automatically here at the top of the report, and you can customize its placement as necessary. At the bottom of the report, there is a section for notes, which you can either input manually or select the pencil icon to open the text editor. Here you can format your text as required, or you can import professionally written notes from PriceJob's template library by selecting Import Note. And here you see a variety of notes organized by category, including services, finishes, legal fees, substructure, structural members, or general. To add a template note, we might choose the category Structural Members, and then select this note here. Final price for steel beams will be adjusted after a structural calculation. We can select this, and then go to the text editor above and make any adjustments needed. So for example, rather than steel beam, we'll change this to flitch beam. We can also add new notes to our templates library if we wish by clicking plus add note. Here we can create a new note. We might make this one just called new notes and save. And then we can add this to our text editor by simply clicking on the new note. If we wish to edit this note, we can click on the pencil icon to make any changes here, or delete the note. Likewise, we can also create new categories for our new notes by clicking plus add new category. Here we might call this one new category and save. And if we wish to make any changes to this new category, we can click the three dots here to either rename it or delete the category. Here under the substructure category is another good example where we can see that this is particularly handy for adding legal disclaimers. Once we've added our notes from the templates, we can edit them here in the text editor and then close this window. And we can see that our notes have been added to our structural calculations report. We can also combine this report with both a cover page and a cover letter. To edit our cover page, we can click the pencil icon here, and we can adjust our logo placement and choose to show either detailed project information, simple project information, project quote information, and for our example, we'll just stick with the simple project information. Likewise, for a cover letter, we can edit this by simply clicking in the field here and typing whatever we wish. We might say price quote is an estimate only. And if we wish to save this cover letter as a template for future use, we can go over to the right hand side and click the three dots next to the template box and give our template a name. We might call this one estimate and save. And now in the future we can come back to this drop down menu and select the various templates that we have saved for quick recall for future use. When you're done, you can print the complete report or export it as a PDF or email it to your clients or contractors directly from within Price a Job. And that's how to use the Timber Flitch Beam Calculator to BS5268. Thank you for using Price a Job.